So you, just like me, might have bought one of those SparkFun boards with an Apollo chip, Apollo module. So that module is Bluetooth Low Energy enabled, so it's great for Bluetooth projects. And the board itself is pretty cool. So the board itself has a connector for an LiPo battery and a charging circuit. So you can charge it by just basically connecting to this USB-C connector, and that will charge the battery, which is pretty nice. It has the JTAG connector, which is pretty badly designed, as in the connector itself leans on the shielding of the module. God damn it. Yeah, so here you can see that gap, how it leans on the shielding. That is pretty badly designed. Yeah, but the module itself, the board itself, the module is pretty cool. And there is a reset button and just a normal button you can use in your app. I also, I have it screwed to my 3D printed jig, so it's easier to connect to the debugger from the J-Link. It's from Seeger, and it's J-Link edu. It supports cortex-m cores, so it's a pretty nice debugger. Also, I have a small keyboard, which uses only 2 buttons for now. They are pulled high with some resistors, and I'm reading the state of the pins. That's because I want to use that board to build Bluetooth keyboard, and unfortunately it's a painful process. The SDK is a bit messy, and it took a long while to be able to actually make something that works. So the idea is that I want to go through the process how I made it work. So yeah, if you're interested in implementing anything Bluetooth on this board, then yeah, you might be interested in watching it. So yeah, let's get to the code itself. So if you want to set up a project for one of those boards, you will have to fetch, and you want to use the Ambiq Suite SDK. You can basically go with Arduino, but Arduino framework stack doesn't work with the Bluetooth functionality. There is no Bluetooth functionality implemented there. So if you want to actually use Bluetooth, you have to go with the SDK. And that's the route I went for, so that's what I'm gonna show you here. So the best way to do that is to fetch the clone of the Ambiq Suite SDK from the SparkFun GitHub, and they use their own additional repository, this one here, boards underscore SFE. That's like the repository with code that supports their own boards. So you can basically git clone this one and then also fetch the submodules. What's important here is that I personally, when I started working on this, the SDK was, I don't remember the exact version, but it was before 2.3.2. So if you look at the commit history of this project, there is upgrade to 2.3.2, and at this point Ambiq went with some free RTOS implementation, which now seems to be mandatory. Before that, it wasn't. There were some parts of free RTOS implementations, but it wasn't mandatory, and I'm not using the free RTOS part right now, so I'm pre SDK 2.3.2. So what you would do is basically make your project, then go git clone this repository. You would first of all create your project, then git submodule or submodule add. I don't remember. Is there a help for it? you can add a module and then change into directory of that module and check out this specific commit before updating to 2.3.2, this one. Otherwise, what I'm gonna show you won't apply. So unfortunately, that's the only. I have a branch at which I'm trying to move to the newer version, but the makefile structure and the structure of a lot of directories has changed, and it's still not working right now. So for now, I'm using the same version prior to 2.3.2. Okay, let's go into the project. And normally, first of all, it's not gonna be a tutorial. I don't necessarily know how to do everything I'm showing you properly. I'm just documenting how I went with it and what I have implemented and what works, what doesn't. You will be able to expand on my work, I hope. So if we look at the project, then you will see that there is, first of all, there is the submodule that I showed you, Ambiq Suite SDK. So that one will give you access to the SDK and the board specific. That's another submodule in the submodule. That's a submodule with the support for the specific boards that SparkFun has produced. And there's Artemis Thing Plus. That's the board that I'm using. So basically, a good way to start is to just initialize empty Git repository, fetch this submodule, and then starting fetching specific no, not fetching, sorry. You basically want to set up your project, so first of all you can fetch the make files which come in boards_sfe. There is the common folder. I think that's the best place to get it from. You can fetch no, they're not here. Things have changed, or I just don't remember. Templates, I think, yeah. Here you have a makefile template, and that's something you can use and start modifying for your project. So what's interesting about that makefile is interesting. Well, first of all, here you have the variables that you have to set for everything to work correctly. I'm gonna show you how I did that. Then there is the defines that might be useful for you depending what you want to turn on in your code. Then there are include paths. Those are parts that you will have to modify to have access to all of the functionality. And source files, the same, you'll have to modify this, add new files. vpath is a path where the building process looks for the source files. So if, for example, you won't be able to find a symbol, then the compiler will complain about symbol not being there, then you will probably have to drop a new source file here. Then the pre-built libraries. So those are the parts that you might need to modify. And everything below that should be probably left untouched unless you want to change some optimization and things like that. But that's of non-interest for now. So I'm gonna show you my makefile. Oh, so yeah, obviously the source files, the parts that you will have to also grab from here will be and I need to check where that is, but you will basically need to grab the linker scripts and the startup. Oh yeah, they're in the same folder, the templates folder. There is the startup GCC, so that's the code that fires off first when the board boots. Does it? it even calls the main function directly. So that's actually the code that executes before the main function. So it fills in sets the stack pointer, does things like that, and then calls the main. So that's something that you should fetch to system. I don't know if that's necessary. There is the main template. Oh, and there are the linker scripts. There are 2 linker scripts depending on the bootloader you're using. SVL is the SparkFun bootloader, I think. So I think that's the one you're gonna use. And like, if you can see on the right, the flash memory origin changes. That's because the SVL linker script compensates for the space in flash taken by the bootloader itself, while the SAB, that's Ambiq bootloader linker file, and that only knows about its own bootloader. It doesn't know about the SparkFun bootloader, because usually it's not there when Ambiq prepares the processors. So you'll use this one. So basically you can fetch everything from here, from this folder, put in your own source folder, as I did. As you can see, here's my main file, my make file, startup GCC. Those are more or less, I think they're the same as in template. Like this, for example, there's nothing particular about it. So, okay, make file, let's go for the make file. As I mentioned, here are some variables that will need to be set, but I'm gonna show it to you soon. As you can see, my includes are, like, there's way more stuff than you can see in the template make file. The same for the sources, there is way more of them. And vpath, also a lot more, in order to find all of those source files that are listed here. Yeah. So here, those are the green scripts are the old scripts that I have been using, which I probably should delete. I have changed the process I'm using to actually do all of that. And that's basically, I have created this env shell script, and that one sets all of the necessary shell variables and paths to the toolchain and the SDK and the debug binaries that I'm using. So here you can see setting up those variables. So COM port is the serial port that is going to be used to upload the software to the board. This is the speed of uploading for when you're using the Ambiq bootloader. That's for the SparkFun bootloader, also the speed. Then there's Python 3 executable. That's because it's the whole bootloading process, uploading the firmware, uses Python and I think PySerial to handle serial communication. SDK path is path to the SDK, so in this case it's just the Ambiq suite SDK. Common path points to the files shared but by all of the boards made by SparkFun. Then there is the board, and that's Artemis Thing Plus for me, and that's basically the directory. If we go there again, boards SFE, and then there's Artemis Thing Plus. So if you're using Artemis, Edge, or anything else, you will use the directory name. And then the board path is made out of the SDK path and the board path, the board name, and then the project path, which is basically the root of the entire project. All of those variables are exported, so they are accessible in the shell. Here you can see there are variables that actually point to the toolchain, which I have downloaded from the GCC ARM non-EABI website. Like if you just put it gcc arm then you will find the toolchain. You can download the version you want. And I'm using the J-Link, Seeger J-Link debugger. So I also downloaded their software to be able to debug, and I'm just pointing to the specific directories. Nothing fancy here. And I also created some aliases for the commands that I'm using. So B is for building the project itself. BB is for building project and libraries. So BSP is like board support. I don't know what BSP stands exactly for. Port support something or something like that. Anyway, that gives you the code that actually handles a lot of things that are board specific. So where is the button, like actually the button handling, the LED handling, things like that. Then there is the hull layer for the Apollo3 that you can also rebuild. And I sometimes modify the make files for those. Now I'm gonna show you how I do that. So I modify those in such a way that I have access to the debug symbols. So let's for example let's go to the board. So I will go to Artemis, BSP, that's the, let's see what BSP stands for, maybe we can find it here. Board support packages, yeah, here it is. Now we know, board support packages. So if you go to the specific board, BSP, GCC, here you have the make file. And I sometimes, if I need to debug something, I might add something to flags in order to be able to build with debug. So that would be like GDB, and that would be, I don't remember, is it like so, or just, oh, I don't remember. Well, I can actually check in my own project, because my project is built with debug symbols. So if I go to my own makefile, no. Oh yeah, so -0, that's the optimization level. Sheesh. Yeah, and I'm using just -g flag, so it can be -g GDB. I think then it uses the dwarf format. I don't know that much about debuggers. I just use them. So yeah, so this is the file that I use, and the aliases. The C is for cleaning my project, CC is for cleaning my project, and those two others, BSP and the hull layer. ITM is for connecting to via the J-Link debugger. You can connect to an serial communication channel. So instead of setting up an UART channel, you can use the ITM and basically connect to a serial communication channel through the debugger, which means that I don't have to connect anything else. I can just open up a window and basically connect to the board through the debugger and print information to the ITM. ITM is not necessarily a pin. Is it a pin? Is it using as SWD, or is it JTAG? Let's go full JTAG. So there is usually like, oh yeah, here. I think it's the those TDO and TDI pins, things like that. I think so, I'm not sure. I would have to double check that. I'm gonna do that later when we actually get to some debugging. Okay, so anyway, that one uses the, oh no, SWO viewer, so it uses like the SWO pin. Is there a pin like that? Told you. Yeah, there is a pin like that, yeah, here. So that's probably it uses this pin. Told you, not amazing at it. Like I actually learned about ITM, and you can actually Google that. That's actually very interesting. I didn't know about that before. So there is the trace macro cell, and there is ITM and ETM. Yeah, so it's an application-driven trace source that supports printf style debugging. So basically output you printf stuff to it. Not that fancy, but it's very useful when you actually want to debug and you don't want to set up a UART and things like that. Okay, flashing uses the same makefile as building and cleaning. It just has like a bootload target. And then there is debug. Debug is basically spawning a GDB process with Python support. It connects to the remote target. Basically, it connects to. I think I didn't set it all up, or did I? Let's check it. Because as I've said, I'm porting to this script. I started doing that today. So if we go, there should be debug script. So if we go debug, that was my old script. Yeah, so I didn't implement that yet. So it actually should be, this one will be called GDB. No, that's a bad idea because we already have the GDB program. So maybe let's call it DBS for DB server. No, this will be DBC for DB client. And this will be DB server. And this DB server will be basically... Oh, damn it. So this will be the actual server that connects to the board, and so basically, as you can see, like I'm just copying functionality from that script because I want to start using that. Yeah, so this will be the actual debugging server that will be connected to the board. And this will spawn a GDB instance that will connect to this server. Yep, that's the idea. Okay, so how do you use this script? That's simple. You just being in the root folder of the project. Maybe let's make the font a bit bigger. You can do maybe a bit late for that, but you can source that env shell script. Yeah, and it gives you, prepends the line with Apollo. So I know that this shell has everything that it needs, like the paths to build and things like that. So now I can see, for example, SDK path. Yeah, looks legit. And everything should be set up. So now with the aliases, I can just do build. And it doesn't work. Oh no, because it's not built, it's just B. Or BB to build everything, or I can do C to clean my project, CC to clean everything, then I can do BB to, again, build everything. It's gonna compile now it's compiling the HAL library, before it was compiling the BSP library. There are some warnings, obviously there are. After this runs, because yeah, it's almost done, it's done, I'm gonna show you what exactly was built. So again, if we go to the source bin directory, then I'm dropping everything here for now. So all of the object files, and those are the final binaries that can be uploaded to the board. I'm using the AXF, I think, isn't it? It's normal elf file, but I think let's see, make file. If we go to bootload target, yeah, there's bootload ASB using the Ambiq bootloader and the Artemis SparkFun bootloader, and this one uses, this one uses bin. What uses this AXF, or what is it? Maybe it's not no, it's an elf file, so it is a binary. Anyway, no idea. I just run bootload, and then, as you can see, like the default bootload target is using SVL, and that's good enough. Yeah. So we are also linking to two static libraries. So one of them is the BSP, as I showed you before. Here it is. And that's via this makefile. In the script I showed you, that's where you can see how it's triggered. Anyways, this is important if you, for example, want to add some pins, like add buttons to pins, like I did for my board, because I have like added that small keyboard I showed you before. Then you can go to BSP pins source, and here you can describe them with, where are they? Buttons. Yeah, here you can describe them. So by default this board has only this one described. I have added two more. Then you actually, then you generate those two files, BSP pins C and H. In order to do that, you actually, let me see if I have that in my history. So that would be Python, yeah. So with the SparkFun repository, there comes a script to generate source file, the C file and the header file out of the source file, instead of doing it manually. So I think I'm in the wrong path. Yep. So I need to go to, yeah, it should work from here. So basically running this, as you can see, it's Python 3, then the script itself, the correct path, and then the path to the source file here. And then you specify, should it be C file or H file, like header or not. And if you do that, that will output to the standard out, and then you can pipe it into the proper file. So for me that would be something like this. And then you pipe this output right into this C file, like so, with this pipe. And then you should have a proper file for actually building and supporting those buttons, which is nice. Oops. Okay, let's go again, because I thought I'm in a Ranger shell, but I'm not. So that's one thing, is that for your board you might need to rebuild this BSP layer, those pins. Yeah, and that's the main setup. So let's say I can delete those. I'm gonna leave the patch. I introduce some changes sometimes via shell script, because I basically keep some of the changes in a patch folder. Yeah, for example, here I'm adding the debug symbols. So I used to do that. I'm not doing that much anymore. For example, okay, not the time for it yet, I think. Okay, I think that would be it for now. I'm gonna add the links to my repository in the description, so you can browse through it, look it up, and that's how I set up the project itself. So maybe I didn't talk a bit about this, like HID app folder is not of importance yet. but as I've pointed out, here are the main files that I use, the linker script. I only used like one source file for now, the make file and the startup GCC. So the make file uses all of those and links to the libraries and the source files from the Ambiq SDK and the SparkFun boards. Okay, I think that's enough for now. I'm gonna post the links below. Yeah, this series might be a bit messy because as I've said, it's not a tutorial. It's something that I'm trying to put together as a documentation and to help others when they are stuck with this pretty crappy experience. Yeah, I think for now that will be it. Okay, thanks.